Okay, so we're going to start talking about algebraic proofs. So here are some properties that may seem familiar, or hopefully familiar, from your Algebra 1 days. Some of these are really basic and seem kind of pointless now, but actually when we get into geometric proofs, they're going to make a lot of sense. So for example, this reflexive property, it says that for every number a is equal to a. So 5 is equal to 5. Why is that true? The reflexive property, something is equal to itself. Again, we won't really use this much now, but when we do get into reflexive or geometric proofs, it's going to be important. Same with the symmetric property. So if x is equal to 5 and x is equal to y, I'm getting ahead of myself. Symmetric property is just if x is equal to 5, 5 is equal to x. Is there really a need to rewrite this right now and say this? No. However, when we do start looking at geometric proofs, it's going to be very important to use this step. Actually, what I was just doing was the transitive property, and that is if x is equal to 5 and x is equal to y, well, because x is equal to x with the reflexive property, rather than us saying that, we can just jump to say y is equal to 5. That is the transitive property. So if x is equal to x, y is equal to 5. What we're mostly going to be using for this section are really these and sometimes the distributive property. So the addition and subtraction properties. So for all numbers a, b, and c, if a equals b, then a plus c is equal to b plus c. And we've seen this before. If I have x is equal to, or if I have, better yet, x plus 5 is equal to 7, I can subtract 5 from both sides. This is something you've been doing for so long, maybe you forget why we can do this. Now, we can do this because whatever you do to one side of the equal sign, we can do to the other. In this case, this is a subtraction property because we're subtracting. It's the same concept for when I add to both sides, except here I'm adding, so that's the addition property. For multiplication division, it works the same way. If I have 5x is equal to 10, I can divide both sides by 5, which is really the same as multiplying both sides by 1/5. So really these two properties here are saying whatever you do to one side of the equal sign, you can do to the other, as long as it's the same property, same operation, and the same value. Substitution we've seen when we did substitution elimination. So if a is equal to b, then a can be replaced. So if I have x plus y is equal to 10, but I know that y is equal to 2, I can say that x plus 2 is equal to 10. Notice I replaced the y with a 2. That's substitution. And then of course the distributive property, where if I have 5 times x plus 2, I can say this is 5x plus 10, where we are multiplying. So a more mathematical way to write this out is that a times b plus c is ab times ac. Notice for each of these terms, if this is b and that's c, this is 5 times b, 5 times c. So that's what we have, and so let's actually go through this now. The whole concept of an algebraic proof is really to get us ready for geometric proofs. Proofs are by no means just in geometry. In fact, if you go on to study mathematics later on, even at something, even at the level of calculus, you will have to do proofs. And mathematicians and statisticians do proofs all the time. So to gear us up, we're going to take a concept that we already know. So if I have this equation 7d plus 3 divided by 4 is equal to 6, and I say solve for d, you can easily solve this for and get d is equal to 3. But with a proof, we want to break this up, and we want to write this into statements and reasons. So not only are we going to do a step, but we're going to explain why we're doing the step. And the reason we do this is to prove, to support our claim. Why can we do something? So you'll notice when I teach, I do this the same way. I explain every step to you. So when you're solving this in a proof, you basically want to do something and then explain why you do it, as if you are the teacher. So the first step we always have, and the first step you can always get, it's writing what was given. So here I have 7d plus 3 divided by 4 is equal to 6. And that's because it's given. That was given to me. And number 2 is what I can do. Now, if I'm solving for d, there are a few things we can do. What's the easiest? Well, it's probably easiest for me to multiply both sides by 4. Why can I multiply by both sides by 4? The multiplication property. Notice with each step, I'm actually numbering it. And the reasons and the statements have corresponding numbers. And they're all in the same line. So step 2 is right across from step 2. Now, if I take this, it might be easier to see on the right side. What is 6 times 4? Well, 6 times 4 is 24. And when I divide something by 4 and multiply something by 4, they cancel out to get 1. What did I do? Well, I replaced 6 times 4 with 24, and I replaced this left side with 1. So this was substitution. So I'm going to write the substitution property. Notice I'm not writing a whole lot for the reason. I can just name a property, or in later instances a theorem or postulate, whatever the name is. All right, what would I do next? Well, if I want to get d by itself, I would subtract 3 from both sides. And why can I do that? That's the subtraction property. And just as I did before in step 3, I'm going to take a look here and say, well, what is 3 times 3? Well, that's 0, so I get 7d plus 0 is equal to 24 minus 3, which is 21. What did I do? I took this operation of 24 minus 3 and I rewrote it as 21. I substituted. So this is the substitution property. Now the cool thing is, you might notice a pattern. Basically, whenever I do some operation, most of the time the next step is going to be the substitution property. So let's see if that holds true here. So what would I do next? Well, I would divide both sides by 7. And so this is the division property. But wait a minute. What is 7 divided by 7? Well, that's 1. And what's 21 divided by 7? That's 3. So what did I do there? That was, again, substitution. I substituted the operation for the value. What was I trying to prove? It said write a 2-column proof for 7d plus 3 divided by 4 equals 6 must equal d equals 3. Did I get that? I did. So I'm finished with my proof. So recapping, we're going to use all of those properties that we've looked at before that you've been using for years, but you may forget the names of. So reference them and take a look. For each step, you basically do an operation and then substitute. Do an operation, substitute, all the way until you get your variable isolated. Now imagine, again, you were a teacher and you were doing this for students. So for me, imagine I were solving this problem up on the board. Well, if I were just solving this linear equation, it would look just like this. I would take you through step by step, and I would say, okay, 7d plus 3 equals 24. What would I do next? Oh, I subtract 3 on both sides, and then I would get 7d is equal to 21. And that's all we're doing here. So I don't know how I get this off the screen. Well, whatever. You get the idea. We'll come back to this. So let's try this one out now. I think that's the next one. Oh no. There we go. This is the next proof. So let's try this one out. So I'm going to go through this one, but I recommend you watching the video. You pause the video, try it on your own, and then watch my steps. All right. So the first step I'm going to do here is I'm going to write out what was given. Always the first step, always. So I take what was given, I write it down. What's the reason? It was given. All right, now if I look here, what could I do to get a by itself? Well, if I were solving this, I would add 5 to both sides. Why can I add to both sides? That's the addition property. Now if I look, what is negative 5 plus 5? Well, that's 0. And what's negative 90 plus 5? That's negative 90. I replace the operation with a value. I use the substitution property. Number 4, if I want to get a by itself, I would divide both sides by negative 6. And I can do that to both sides of an equation because of the division property. And finally, what is negative 6 divided by negative 6? It's 1. And negative 90 divided by negative 6 is 15. What I did there was I substituted those values in. So this is the substitution property. And I got what I was trying to prove. So yet again, I'm writing down each step, writing why I can do that, and then substituting in for the operation. All right, let's try this one next. So here, first step is going to be given. So that's what was given. And again, try to do this on your own. Pause the video here, and then I'll go over the reason. All right, so the second step here, if I have parentheses, what I can do is I can distribute here. So I get 15x. Actually, really, if I wanted to really write each step appropriately, I would do 3 times 5x plus 3 times 1 is equal to 13x plus 5. Why can I do that? That is the distributive property. Now, in the next step, I'd actually do this multiplication. So what is 3 times 5? That's 15. 3 times 1 is 3, and then I get this other side here. So what did I do there? That's the substitution property. Now I want to get x by itself, so what I could do is I could subtract 13x from both sides. Why can I do that? That would be the subtraction property, because I am subtracting from both sides. Now what is 15x minus 13x? Well, that's 2x. 13x minus 13x is 0. So I'm left with plus 5. What I did there was substitution, so that's the substitution property. Similar there. I could subtract 3 from both sides, so 2x plus 3 minus 3 is equal to 5 minus 3. That's the subtraction property again. And I can actually do that subtraction, so 3 minus 3 is 0, 5 minus 3 is 2. So this, what I did there was substitution, so that's the substitution property. And now I can divide both sides by 2. So if I divide both sides of an equation by 2, I'm using the division property. And what is 2 divided by 2? Well, that's 1 and 1. So I get that x is equal to 1 by substitution. I got x by itself. I showed that x is equal to 1, so my proof is complete. So here are those steps for you to revisit. Notice I have an operation, substitution, operation, substitution, operation, substitution, operation, substitution, and I'm done. All right, one more. Hopefully we're feeling a little bit better with this. So I start off with what I'm given, which is 7y minus 84 is equal to 2y plus 61, because that's given. What I can do is I could subtract 2y from both sides, so I get 7y minus 2y minus 84 is equal to 2y minus 2y plus 61. That is substitution. Sorry, that's substitution. I'm getting ahead of myself. That is the subtraction property. Now actually, if you notice here, I'm throwing this negative 2y right in the center. If I really want it to be exact and really want it to be, really drag this out to a painful extent, technically I should put this negative 2y on the end and then reorder this. Now if I reorder that, I would be using maybe the symmetric property or the transitive property. Well, actually, symmetric property or reflexive property. Chances are I've been using most of this, I'd be using the symmetric property. So I'd say 7y minus 84 minus 2y. I'd rewrite that as 7y minus 2y minus 84 because of the symmetric property. Now, I'm not actually going to write that because it's not too important for us right now. We don't want to spend 20 minutes doing one proof. So right now I'm just going to plot that negative 2y right in the center, say, hey, I'm going to subtract this, and then actually do the operation. And that is because of substitution. Next, I can add 84 to both sides. Whoops. And that is the addition property. Can simplify this, so I get 5y is equal to 145. And I can do that because of substitution. And I can divide both sides by 5 because of the division property. Finally, I can reduce this, so I get y is equal to 145 divided by 5. That is going to be 29. And so that is the substitution property. Now, I don't have the best handwriting in the world, and these are somewhat not level, but you can see generally these steps are across from each other, and they are numbered. So make sure you number your steps. Make sure you show your work here. Label each step appropriately. Make sure you're numbering your steps. We do not want to put letters for the steps. And then go through these and make sure you're using the appropriate properties. We're going to get lots of practice with this, so feel free to ask questions, but definitely take your time and go through this and really put in some good effort.